Hey, John, can you hear me?
I can hear you.
Okay, good. Thanks. I'm going to try to see if some more people are going to come on. I know some people was trying to get on there, but I have a YouTube channel that has all of my videos uploaded to it. because Canvas couldn't handle it. So I had to find another way to get the videos. And so I've set up a YouTube channel for all my videos. So that's what I'm been doing. And it takes a while to upload because some of the files are big, but I have figured out a way to get around some of that. So I've been doing a lot of troubleshooting to figure all of this out. Let's see if some more people are going to come on. I only see 2 so far. John, can you see the PowerPoint presentation?
Yes, ma'am.
Okay. Well, I'm going to go ahead and get started. We are on chapter 9, and today for chapter 9, I am going to split it up into 2 parts because it is a long chapter. We're going to get into firearms, tool marks, and other impressions. And I know that, yeah, it's up on my desk. I did bring home some of the different firearms and tools and stuff. And I remember telling you guys and showing you guys earlier in the semester that a few weeks ago, Dr. Craig actually shot a heart for us. And I have to go to campus and get that particular bullet. But he shot a heart for us, and we're going to look at the microscope and look up under the microscope, and I'm going to shoot a video of it, of that. Can you hear me? Hello?
Yes, ma'am.
Okay. All right. All right, good. Make sure you guys mute your mics so that it won't be too much feedback. So let's get into it. We got such things as handguns, very popular. You got your single shot pistols. They only fire one round at a time. Then you got your revolvers. So revolvers are handguns that have the chamber that you can spin around. You got swing out ones, you got break top ones, and you got solid frame revolvers. I know those were very popular. I think my brother still has my dad 45. He loves it. And then of course, you got your semi-automatic pistols. They feature a removable magazine, fire one shot per trigger pull. So you have those. What type do I have? I have a Glock. I don't have it here with me because I have kids now, but I do keep it at my uncle's. So I do have that. And then my sister have my other stuff. So here, what you see is a swing out revolver that swing out to the side that can be loaded. And those are most of the ones that you will see. And normally you can put about 6 bullets in there. And then this is a semi-automatic pistol here. Most of the time, most police officers and people in law enforcement like to carry those. Now, in this one, this is a semi-automatic long gun here. And then this one is used to expel the spent cartridge case, load the next round, cock the hammer, and all of that. And those are all different types that are out there that is based on this type of gun. Now, you can have long guns. They can be single shot, they can be repeating, they can be semi-automatic or automatic. You can have the ones with shell ammunition that contain numerous ball-shaped projectiles called shot. You can have the narrowing of the smooth barrel called the choke of the shotgun, and it can concentrate the shot when it's fired. Now, and then you can have rifles. So that's feature a barrel with lands and grooves, and bullet ammunition impressed with lands and grooves during firing. So even when you put the bullets in there, these guns, they make some type of styration on the bullet itself. Now, right here, this is a bolt action long gun, use movement of a bolt mechanism to expel the spent cartridge case and load the next round and cock the hammer. And so this is one like this, and yeah, I think that was like one of the first ones I ever shot in my whole life. It's something like this, and this is what my dad had. Now, shotguns are like rifle firearms. A shotgun has a smooth barrel. Now, shotguns generally fire small lead balls or pellets. So like my nephews and stuff, I bought them pellet guns. They are not impressed with any characteristic markings that can be related back to the weapon. Now, the diameter of the shotgun barrel is expressed by the term gauge. The higher the gauge number, the smaller the barrel diameter is when it comes to that. So that's how they really deal with the shotguns. Now, first of all, what we got to look at is structural variations and irregularities caused by scratches, nicks, breaks, and wear. You may be able to do this. You may be able to relate a bullet to the gun, a scratch or an abrasion to a mark to a single tube, or a tire track to a particular automobile. So you should be able to do all of that. And so that's what we're looking at is what other impressions do we see when it comes to a crime. And individualization, a goal of all areas of criminalistic. Basically what people want to look at and really see is basically, can we examine this and how can we examine this in order to catch a criminal? That's what they're going to look at. And they really look at the types of firearms, the tools, and everything else. Now, you have gun barrel markings. Now, gun barrel markings, that's on the inner surface of the barrel of the gun. And there's leaving markings on the bullet that passes through it. Now, each markings are particular to each gun. That is how they really design it so that you are able to identify it. So that's what they are starting to do. Now, how do they produce these guns? They produce them from a solid bar of steel that has been hollowed out by drilling. And then the microscopic drill marks left on the barrel inner surface are roundly irregular and serve to impart uniqueness into the uniqueness of each barrel. So basically what they're saying is they take a piece of a steel bar and then what they do is they drill it out, they hollow it out. And then the drill marks left on the barrel is sometimes they're irregular because every gun, even though it's the same type of gun, unless they're using the same drill pretty much, it's going to make the same striations. And so that's what they try to do. So sometimes the microscopic drill marks left on the barrel inner surface, sometimes they are randomly irregular and serve to impart a uniqueness to each barrel. So that's why they have to say, yes, this bullet came from this particular gun. They have to really examine all of that really closely under a microscope. Now, when they manufacture the barrel, it always requires impressing its inner surface with spiral grooves, and they call that rifling. And so that's what they do. So they want to make sure that they impress the inner surface with those spiral grooves. That's another method of identification. So a lot of times when they're actually making the gun, this is what they do. They are doing identification. Now, when it comes to rifling, you got to cut all the grooves in one pass with a cutter, and that cutter is called a broach. Now, pressing all the grooves at once into the barrel with a tool, they call that a button. Or you can hammer forge the barrel over a mandrel containing the reverse image of the rifling. So you can do that. There's different ways that they actually do the rifling, and that's what they have to do. Now, when it comes to that, the surface of the original bore remaining between the grooves, those are called lands. And those grooves serve as a guide to fire the bullet through the barrel. So they have to put the spiral grooves in there, but then the bullet has to come through there, and that helps the bullet projectile out and it parting a rapid spin to ensure accuracy. So they have to spiral it in there, and then when the bullet goes through there, it spirals, and that makes the bullet speed up and go faster. Now, the diameter of the gun barrel measured between opposite lands, that tells you the caliber. Now, once the manufacturer chooses the rifling process, the class characteristics of that weapon will remain consistent. Each will have the same number of lands and grooves with the same approximate width and direction of the twist. So that's what they do. And this is the interior view of a gun barrel. So in there, it's going to have those grooves and those lands. And basically, those lands are the ones that's going to put markings on the actual bullet itself. That is what's going to happen. Now, the striations are the fine lines that are found in the interior of the barrel. These striations are formed from the individual characteristics. Now, that inner surface of the barrel of the gun, that leaves the striation marks on the bullet passing through it. So striations are in the barrel, and those striations, when the bullet passes through it, are put on the bullet. And so that is very important, how to identify that. Now, this is a bullet right here that with rifling markings of the barrel when it emerges from the weapon. That's how it looks. And what I'm going to do is the one that Dr. Craig shot the heart, I'm going to make sure I try to put that under the microscope and take some pictures of it so you guys can actually see that. Now, this is a photomicrograph of two bullets through a comparison microscope. The test bullet is on the right, the question bullet is on the left. So, do you see some differences in the two? Do the striations look the same? And y'all can respond in the chat if you got a chat window. So I want y'all to take a look at that and tell me what you think. Does it look the same? Are they from the same gun? Maybe, maybe not. You guys tell me. And now, when we talk about that, no two rifle barrels will have identical striation markings. Now, the number of lands and grooves in the direction. Now, what they have to do is, and I agree, Nathan, I think the angle is that as well. Let me flip back to it. Yeah, it may be off just a little bit, but they do look the same. Or the same type of, it could be the same type of gun. Now, what they're saying here, no two rifle barrels will have identical striation markings. And what they basically saying is, a lot of times when you hear, if you talk about the different shows and you hear them talking about actually addressing shooting, what they have to do is sometimes is actually fire a bullet from that particular gun and compare the bullets. That's normally what they do to see does it actually match up. But sometimes that's what they have to do. So they may fire it from a test gun, but they also have to fire a bullet from the actual gun itself to see if the striations match up. And that's the best way to actually tell whether or not it was fired from that gun, is to make sure. Now, What they do is here, this is a bullet holder beneath the objective lens of a comparison microscope. And that's what they're going to do. They're going to put the bullet in chapter 8, you saw the comparison microscopes. And that's what they're going to do. They're going to put a test bullet in one side. They're going to put the actual bullet from the crime in the other side. And they're going to compare the two. So that's what they're going to do. Now, any differences in these class characteristics immediately serve to eliminate the possibility that both bullets traveled through the same barrel. Now, one of the goals that they really look at is oh goodness, I'm getting tongue-tied. Individualization is a goal of all criminalistics. So you got to do that in firearm investigation. They got to make sure that they have to isolate and make sure did the bullet come from that gun. And so that's the reality of it. That's even when if you have an officer involved shooting and they have to turn over their weapon. That's one of the things that they have to do because they really have to go through and test the weapon to make sure. Did it come from the officer gun? Yes or no? And so that's what they have to do normally if the gun was discharged. Most of the time, they have to turn it in for examination in the investigation. So that happens. Now, the comparison microscope is the most important tool to firearm examiners. Two bullets can be observed and compared and viewed simultaneously within the same field of view. Now, this is what they got to look for. They got to have identical widths, the longitudinal striation. They must coincide. They have to be the same. And that's what they're going to be looking for when they own the comparison microscope. Now, this is the comparison microscope we showed you in last chapter. And this is a picture, and they put this back in there again, and it's joined by that optical bridge. So that's what they're going to do. Like I said, they're going to have one bullet on one side, the other bullet on the other side, and that's what they're going to do. Now, again, like the shotgun, like rifle arms, the shotgun has a smooth barrel. Now, the shotguns generally fire those small beads or pellets. So that's what it is when it comes to shotguns. Those pellets are not going to be impressed back on there with those. Now, the diameter of the shotgun barrel is the term gauge. So for handguns, they use caliber. For shotguns, they use gauge. The higher the gauge number, the smaller the barrel diameter. So caliber and gauge, that's what they're going to use when you're talking about firearms. Now, when you fire a weapon, the act of pulling the trigger, it serves to release the weapon's firing pin, causing it to strike the primer, which in turn ignites the powder. That is what happens. Now, what happens is when you do that, the gases in there that really generate by the burning gunpowder, that gas pushes the bullet out. And when I talk about this, like from a chemistry standpoint, basically what it's saying is that the gas is so strong it can push it right straight through the barrel, and it's bent the cartridge or the shell back with equal force against the breech face. Basically what it is, if you shoot the gun, the gases that is released by hitting that gunpowder, sometimes they call it blowback, and that can happen to whereas it is so powerful, and that's what it is, the gases that's being released. And so I know a lot of times people are like, really, that's what happened? But yes, even in firing a weapon, you still got chemistry going on. And so that is something that, I look at it from that standpoint that, a lot of people don't understand that. They just think, well, okay, I'm just shooting a firearm, but there's a lot of chemistry going on within that because you're looking at gases. Now, the shell itself is impressed with markings by contact with the metal surfaces of the weapon's firing and loading mechanism. So those striations are going to be put on there with the contact through those metal surfaces. The landings, the striations, all those different type of markings are going to be put on the bullet itself. Now, what do they like to do? When you fire a weapon, they want to compare the cartridge. You got your firing pin, the breech face, the ejector, the extractor mechanism. They also have distinct signatures. So the shape of the firing pin will impress into the relatively soft metal of the primer on the cartridge face. So all of that stuff is going to happen. I'm going to have to see, because probably I'm going to split this part up into two parts if I don't get through all of it today. And then we'll take a look at basically the bullets that I have. I did bring some of them home, and then I'll be able to shoot some videos and put them up on the YouTube channel. I know you guys looked at some of it before when we examined it in class, but we'll take a deeper look at some of these as well. Now, the cartridge case is rearward thrust is impressed with the surface markings of the breech face. So you have that going on. So the cartridge case in its rearward thrust is impressed with the surface marking of the breech face. Now, what about this? What can happen? Now, basically with this, there are several things. You can look at computer technology, and it may be possible to actually make fingerprint files or store these files that has the characteristics of all of this stuff. Now they're making databases for all of this. So computer imaging has made it easier to make databases for all of this. So one particular database, the National Integrated Ballistics Information Network, they got a database file from bullets and cartridge casing retrieved from crime scenes or test fired from retrieved firearm. Now, when they do this, they actually often link a specific weapon to multiple crimes. And so a lot of times if a weapon been stolen, and I know, especially here, not only in Mobile, but other places, a lot of people don't like to lock their cars, and then their weapon gets stolen out of their car. A lot of times people don't bring their weapons in the house because they have kids and they don't want the kids to get a hold to the weapons. I'm one of those people. I'm like that because I don't like to do that. But what I'm looking into now myself is a biometric case so that I can keep my gun in, and so the kids can't go into it at home, because my kids pretty much can get into anything. And so that's what I'm having to do. So they can do that, and they have a database of all these different crimes and what firearms were used in those particular crimes. Now, when it comes to that, it does boil down to the forensics examiner. They got to make a decision as to whether or not, if that's right. Is it the right bullet? Did it come from the gun? Do it match up? They have to make sure of that, because 9 times out of 10, that evidence is going to be used. And with that evidence is going to be used, they got to make sure they are right. And so it does boil down to the examiner doing their job. Now, here you're looking at bulletproof configuration. Now, what they're doing is here, it's just showing that, hey, they're going to look at the specimen, they're going to put it in there, and then they're going to put it in a printer, modem, high resolution monitor, a system monitor, all of that. So they are setting up a configuration. They can do that. And so that's what they're going to do to put it into the database. Now, let's just say that you have this particular, you have a particular weapon, and then you discharge that weapon. So when the firearm is discharged, sometimes the reaction that's in there, it doesn't completely go to fruition, meaning that not everything burns. All of the gunpowder doesn't burn, so sometimes you're going to have unburned and partially burned particles of gunpowder, in addition to smoke propelled out of the barrel along with the bullet toward the target. If the muzzle of the weapon, when they say close range, is sufficiently close, the products will be deposited onto the target. And sometimes that is very evident, and you will see that. Now, not only does it go on to the person that got shot, it also be some residue on the person who shot the gun too. So it goes both ways. So it's going to be on there. That's why you can see it close range, point blank range, all of that. You'll be able to tell how close they are. So when looking at the distance, the distribution of the gunpowder particles and other discharge residues around a bullet hole permits an assessment of how far or what the distance where the handgun or the rifle was fired. So that's what they're going to look at. Because when you look at that, they're going to do it based on, and the term that I like to talk to with my students is called density, and it's electron density. Same thing with gunpowder. It's going to have a density of the residue that is there. And so that's what you see. Now, the precise distance from which the handgun or the rifle has been fired must be determined by means of a careful comparison of the powder residue located on the victim's clothing or skin against test patterns when the suspect weapon is fired at varying distances from the target. And so they can sit up there and test fire the weapon, and then they can look at, wait a minute, how far is this away? And that's what they can do. So you can compare the test and the evidence patterns. The examiner may find enough similarity in shape and density upon which to base an opinion as to the distance of which the shot is fired. So basically saying is, okay, you can look at the test, you can look at the evidence patterns, the shape and the density, meaning that wherever that bullet was, there's a density of gunpowder residue that's going to be around it. And so you can look at the shape of that and the density of that, and you can find out pretty much how this happened and when this happened. So you can actually do that. Now, how can you determine it if you don't have a weapon? That's the question. In cases where the weapon is held in contact with or less than 1 inch from the target, you're going to see what you call a star-shaped pattern around the bullet hole entrance, surrounded by a rim of a smokeless deposit of different lead. So the vaporless lead, you're going to see that there, because you can be able to get a little machine, a little scanner, and it can tell you where it is. And so a lot of times you can look at that and you can tell that just by that. Now, that halo of lead smoke deposited around a bullet hole is normally indicative of a discharge 12 to 18 inches or less. Now, the presence of scattered peaks of an unburned, partial burned powder grains with anything that is accomplished or accompanying soot is often observed at a distance 25 inches and occasionally as far as 36 inches. So roughly 2 to 3 feet. More than 3 feet, you're not going to see that deposit. And so usually you see it's just a dark ring around the hole, and they call that a bullet wipe. Now, this is test powder pattern made with a 38 special Smith & Wesson fired at the following distance from the target, and that is contact. And I actually like my Smith & Wesson guns. By the way, side note about me, I do collect guns, but I don't keep them at my house right now because I have kids. And so I keep them away, but I do collect them. So don't think I'm strange or weird or anything like that. So I'm a country girl, and I grew up in the country. So my dad taught me a lot of things. I know how to fish. I know how to hunt. I know how to bow hunt too. So I do have that. I prefer to bow hunt versus shooting a rifle. That's just me. But I do have several handguns myself. Like I said, I just don't keep them at the house because I have little kids. And like I said, I am going to keep one, but I got to buy a biometric gun safe. So I'm just trying to save up a little money to buy that so that I can keep it in the house. And with that, being a foster parent, you know, they have to check all of that to make sure that the kids are safe and all of that. So for now, I just decided, hey, I'm not going to keep a gun here at all, even though I have them and have permits for them. Now, what about test powder patterns? So this is the 38 fired 6 inches away. So what I was talking about, if you see there in the picture, it makes a certain type of density residue. And then the further you get away, the less you see. So right here, let's see, they did contact. And see, for the contact one, you see it, that's density is just right there. So it just a lot of density right around there. So it looks like a dark gray pattern. And so the further you get away, it spreads out, and then it spreads out even more, and that's 12 inches. So they did on contact, a half a foot, 1 foot. This is a 1.5 feet right here. You see that they're spaced out kind of differently. And then this is a contact shot. And so if you look at a contact shot, they're gonna take a look at the clothing, and then what they normally do is they swab the clothing and everything. And so you see there, you got the bullet, they little ruler there that they can measure the contact shot and everything right there. Now, here go a shirt bearing a powder stain. Now, when they look at this, they look at it under normal light, and then they do an infrared photo of the same shirt. And so that's what they have to do. They have to look at it and take the actual picture of the shirt itself, and then they take an infrared photograph of the same shirt. And that's how it looks. And so you can just see the powder hole and all of that under infrared. Now, what do they do? Now, basically, when it comes to suspects, and they want to look at, okay, did this person fire the gun? What they're going to do is do this adhesive stuff, and then they're going to basically take that and collect your hand, collect residue off your hand. That's what they're going to do. Basically, they're going to take off some skin. It's not that much. It's not even skin, but sometimes it does happen where they take off a little bit just to see if the gunpowder residue is actually in there. So these are adhesive stubs used to sample a suspect shooter hands. And then that's what they do. They take the adhesive and they just rub it on there. They stamp the hand and all of that stuff. And just to make sure that they can get prints. Not only prints, but just to see if the residue is on there. So that's what they do. And then you see the nice little how they marked it, and they have on gloves so to make sure they don't do any cross contamination. Now, when it comes to gunpowder residue, what they're going to look at is basically evidence to try to see if there's residue on there. They're going to take it into a laboratory. They're going to examine it under a microscope to see if there's any gunpowder there. That's what they're going to do. So they also going to run some chemical tests. There's one called the grist test, and the grist test is used to determine whether or not gunpowder residue that are there. And so sometimes gunpowder residue is there, but it's not visible. The firing distances involving shotguns must be related to test firing. The muzzle to the target can be established by measuring the spread of the discharge shot. So even if it had a silencer or something on there, they can look at it and tell. Now, when you are looking at this, and basically what they're saying here is, hey, when you fire a weapon, that primal residue, the gunpowder residue, and the primal residues are going to blow back toward the shooter. So it's going to be put on the firing hand of the shooter. So that's why they got to rub their hands and test their hands, because the blowback comes back on them as well. So traces of the residue are going to be there. Examiners measure the amount of barium, their antimony on the relative portion of the suspect's hand, the thumb well, the back of the hand, and the palm. So that's what the places they're going to look at: the thumb well, the back of the hand, and the palm of the hand. That is where they're going to look at for that. Now, they also got to look at, when they look at that, they're going to look at it under the microscope. One of the words that scientists like to use is morphology. And that's the word you see there. Morphology basically means that they're going to look at the residue, they're going to examine it, and they're going to see whether or not those particles are on your hand. And when they're looking at the morphology, they're basically looking at what's the shape of the particles, what the particles are made of, all of that. And they're going to look at those elements to just see whether or not that person has fired it, they just handled it, or whether they near it. And so they can look at that and just tell whether or not that has happened. Now, how do they collect it for evidence? And I know you guys have seen this before. How do they collect it? They hold the weapon by the edge of the trigger guard, or by the checkered portions of the grip. Before it's sent to the laboratory, they got to take all types of precautions, because they got to make sure they don't want the weapon to accidentally discharge. So they want to make sure of that. Now, most of the time what they're going to do is they're going to unload the weapon. When a revolver is recovered, the chamber, their positions, and their corresponding cartridges has to be reported. So if they get a revolver, they have to record all of that down. How many bullets was in there? Which chamber the bullets was in? All of that stuff. The position, all of that. They have to record all of that. And a lot of times what they do is they'll take pictures of it and make it in their notes as well. Now, you have firearm evidence collection. Also, you usually gotta put a tag on the trigger guard, and then you gotta establish what they call chain of custody. So it goes in, when it get checked out, the forensic person got to check it out. They got to put it back in the evidence collection box, all of that stuff. So it has a chain of command that it has to follow. And what goes with it? Bullets, the cartridge casings, shotgun shells, anything that is collected got to be in an evidence container. And you guys saw that at school where we had that in there. Now, one thing that they also have to be careful of, because some bullets are made of really soft material, soft metal, they got to make sure that they don't mess up the styrations. And so sometimes you can actually, even by putting your fingerprint on it, and mess up the styration markings on the bullet. And so you got to avoid that. So sometimes what they do is they may even pick them up with plastic tweezers or something like that. They don't even want to pick them up with their hands because they don't want to damage the bullets themselves. They also do this. They sometimes wrap it in tissue paper. I've seen that before placing it in a pill box or an envelope for shipment to crime lab. So they have also done that. So they wrap it in tissue paper just to make sure something soft to keep from damaging it. Now, criminals try to be really smart. What they try to do is every gun has a serial number. And a lot of times what they like to do is they like to grind or file off the serial number so it don't get traced back. Well, now they got a lot of technology that is out there that even though you have filed it off, they can still try to retrieve it. And so now sometimes our forensic scientists have to actually recreate that, not create a new number, but try to recreate the number that was on the gun itself. So a lot of times criminals like to file off that serial number, especially if the gun been stolen. They'll file it off. Now, how do they restore it? They do a lot of chemical etching because the metal crystal stamp zone are placed under a permanent strain. And it extends a short distance between the original numbers. So they can actually do that where they can produce the serial numbers. And so sometimes, yes, they have to chemically etch it. Usually with that, it involves some acids that they can actually put on there. And then when you put the acids on there, they can actually draw up and you can still get the numbers off of there. And they usually doing that, and when they're applying it up under a microscope. Now, the last part of this chapter, we're going to talk about tool marks and other impressions and stuff. Now, with a tool mark, there's any impression, cut, gouge, or abrasion caused by the tool coming in contact with another object. Now, when you do this, you can have examination of the impression. It can reveal certain things. It can reveal the size and the shape of the tool. That's what it can do. Now, what about the marks? Now, certain tools, certain marks, even certain knives, the way that they are made, they're going to have some type of identification that is on there. And usually that would make that particular tool identifiable. And what you want to do with that is you want to be able to make sure that tool can be individually identified. And so that's what they say in here. Any imperfections that are on there and all that, you will be able to see that. And it's the presence of that that makes it so different. That's why they say, hey, you can find this tool and it is sold, this particular brand, this particular lot is sold at this particular store. And normally you can find that. Now the shapes and the perfections of those imperfections are further modified by damage, wear during the life of the tool. So you can have a knife that you can have for about 20 years and you can have different things on there that identifies it. Different damage, wear and tear, handle, it may be broke somewhere, a chip on it. So anything that can identify it. Now, the comparison microscope is used to compare crime scene tool marks with test impression made by the suspect tool. So they do that. They go back when they recreate the crime scene, like if they stab somebody, they're going to look at it and they're going to try to recreate it to make sure that, hey, does it match up? The entire object or part of the object bearing the tool mark got to be submitted to the crime laboratory for examination. And so that's a part of the examination. They have to go through, they have to recreate it. They sit up there and actually recreate it so that you can tell whether or not it's actually real and it's the same element. Same tool that was used in the crime. Now, what happens is they can't fit the tool into the tool mark. They can't do that. They have to recreate that, because if you try to put it back in contact with it, they say they're going to question the evidence and it'll look like somebody trying to frame somebody. So they're going to question that. So they have to recreate it. They cannot, hear me you guys, they cannot do anything as far as that. Now, there are other impressions that you got to keep in mind. You can keep in mind shoes, your tire, fabric impression. That is important evidence. You gotta photograph it first before it's even removed from the site, from the crime scene. You gotta have a scale in it, and you gotta show all details of the impression itself. Now, there are other impressions that are going to be on there. You get glass, you're going to get paper on the floor, you're going to get tile. All that evidence is taken back to the lab. If the surface cannot be submitted to the lab, what they're going to do is they're going to try to preserve the print similar to lifting a fingerprint. So a lot of times we did shoe prints and all of that earlier. They're going to try to make a mold out of it some type of way and take it back to the crime lab. That's what they're going to do. They're going to take a lot of pictures of it. Now, shoe marks, tire marks, when they're at a scene, they're going to cast it and they're going to take photographs of it. That is what they're going to do. Shoes and tire marks, they're going to take pictures of it. And normally that's what they're doing most of the time. They're taking pictures and then they're going to photograph it. That's what they're going to do. Bloody footwear is very faint or where the subject have tracked through blood, leaving a trail of bloody impressions. That's what they'll do, chemical enhancement. They can latent or nearly invisible blood impressions. So they are going to do that. So if it's bloody, they're going to try their best to take pictures of it, and then they're going to do a chemical enhancement of it to make sure that they got what they need. That's what they're going to do. Now, there are points of comparison. You got a lot of number of points of comparison. So, test impressions, what source they originated from, and they can only originate from one source. And so you got to have those points of comparison. So you got to have a sufficient number of those, or the jury is not going to believe you, and you got to be able to have that evidence so that it can be presented. And so that's really important when it comes to that. And lastly, I'm surprised I got through all of this fast, but a lot of this was a lot of pictures showing you guys different things. Now, they got a lot of new software, websites that make shoe prints, tire impressions comparison. Also, and if you look in your book, bite mark impressions on the skin, foodstuffs, proven to be important evidence in homicide and rape cases. Bite marks on the skin, food people have eaten, all of that stuff. So this is very important. This is all for chapter number 9, you guys. Like I said, I am recording this. I'm gonna turn back on my video real quick. What I wanted to let you guys know, on Canvas, I have started putting in all of your concept maps. So you guys go ahead and start doing your concept maps. Your next exam is gonna probably come most likely maybe next week. I'm trying to see. So since I finished up chapter 9 today, we'll go ahead and do 10 on Monday, and I'm going to go ahead and put the quizzes up and open the quizzes up as well. So the concept maps are already open. I just opened those this morning. Let's see, your quizzes are going to probably be open later on today and tonight. I'm going to start office hours tonight, possibly around 9 p.m. once I get the kids down. Usually they've been kind of hard getting down lately because their schedule is a little bit out of whack with them being at home. But once I get them down, if you got any questions or anything, please email me. like I said, I'm gonna try to do a Zoom meeting where all of my classes, if you just want to pop in, ask questions and stuff, I will send that out. YouTube, Dr. Wanda Jones classes videos. You guys have a playlist. When I stop recording this and end the meeting, it got to convert. And usually it takes about an hour to an hour and a half to convert the video over, because it depends on because I have satellite internet. And so if it's a little cloudy, it may take longer. If it's sunny like it is today, it just depends. So sometimes it may take a little longer, but it will be posted. So if you need to go back over it, it's fine. As far as your PowerPoints, they are already on there. So you have your PowerPoints, you can go through them and review them. Like I said, I will let you know, but I'm thinking we may have our first online test next week. The online test is going to mostly be multiple choice, true, false, and maybe a little bit of matching. Excuse me. And that's pretty much it. So those will be open. So like I said, if you got any questions or anything, please let me know. Peyton, I sent you an email, so I'll get with you a little later. You guys, that's it. I'm going to close the class out. Let me know if you need anything. I miss you guys. Talk to you later. Bye.